Hello, this is Dr. Brown. In this lesson, section 7.7, we're going to look into how do we generate graphs of the tangent, cotangent, secant, and cosecant functions. Basically, we're going to be looking at graphs of the function a times tangent of omega x plus b, and also cotangent of omega x plus b, where b and a are constants. We're also going to look at graphs of a cosecant of omega x plus b and a secant of omega x plus b, where a and b are constants. Notice omega, we pronounce it omega. And in order to graph these functions, we're going to make use of some identities that we already know. Note that tangent is equal to the sine of theta divided by the cosine of theta. It's also equal to, on the unit circle, it's equal to y over x, the y value on the unit circle divided by the x value. The cotangent, you will not find on your calculator, although you will find tangent on your calculator. But cotangent can be calculated by cosine of theta divided by sine of theta, and it's also equal to the x value on the unit circle divided by the y value. Secant theta is equal to 1 over cosine theta, which would also be equal to 1 over the x value on the unit circle, and cosecant would be equal to 1 over sine of theta, which is equal to 1 over the y value of the unit circle. So let's go ahead and take a look at tangent. And in order to get a handle on this, I put together the unit circle. And remember, the tangent function would be equal to the y value divided by the x value, or the b value divided by the a value on the unit circle. And we're going to pick several angles to calculate the tangent for, and then we will transfer them to the other slide. And we're going to start out at the angle of minus pi over 3. Which is the same as 5 pi over 3. And the tangent of that would be the y value divided by the x value, which is minus the square root of 3 over 2 divided by 1/2, which is minus the square root of 3. So on the table here, at minus pi over the square root of 3, the tangent is minus the square root of 3. So the x and the y value would be as given here. Now look at minus pi over 4. The y over x value is equal to minus the square root of 2 over 2 divided by the square root of 2 over 2, which is equal to minus 1. So we'll put minus 1 for the angle minus pi over 4. Now, for minus pi over 6, the tangent would be y over x value, which is minus 1/2, divided by the square root of 3 over 2, which is equal to minus 1 over the square root of 3, which is minus the square root of 3 over 3. And as you can see on the next page, for minus pi over 6, we've got minus the square root of 3 over 3. And the decimal value is given there also. For tangent of 0 degrees, it's going to be the y value divided by the x value equals 0 over 1. So the tangent of 0 is 0. And notice going from minus pi over going from 0 to pi over 6, and then to pi over 4, and to pi over 3, the coordinates are exactly the same, except the y values are positive. That means that for pi over 3, sine of pi over 3, it's going to be the negative of what we got down here. It's going to be the equal to, tangent of pi over 3. Tangent of pi over 3 is going to be plus the square root of 3. Tangent of pi over 4 is going to be equal to 1. And then tangent of pi over 6 is going to be the square root of 3 over 3. So we put all these on the table on the next sheet and then draw the graph. Notice that it's an odd function. And as the angle gets larger, the value of tangent gets larger. And notice that if you try to look at tangent of pi over 2, it's equal to the y value, which is 1, divided by the x value, which is 0. So it's undefined. So we have on this graph the value of tangent of pi over 2 undefined, or actually it's approaching infinity. And so basically, as x gets closer and closer, it gets closer and closer to infinity. The same by the same token, as the value of the angle gets closer to minus pi over 2, it goes down to and approaches minus infinity. And you can see, expanding this table a little bit, at pi over 3, the tangent was 1.73. As x gets a little larger, which is closer to pi over 2. By the way, pi over 2 is approximately 1.5708. So at 1.5, the value of tangent is 14.1. At 1.57, it is 1255, getting very large. At 1.5707, the tangent is 10,000, and it goes to infinity. So it's undefined at x equal pi over 2. So notice that if we graph tangent of x, not just from minus pi over 2 to plus pi over 2, but keep on repeating, the tangent function will repeat itself with a period of pi. So notice we have 0 at the very beginning, go over pi, and we've got 0 again, go over to 2 pi, and we're 0 again. And these curves replicate themselves with a period of pi. Notice the domain of the function is x between minus infinity and plus infinity, but x cannot equal to n pi over 2, where n is odd. So n can't be 1 pi over 2, 3 pi over 2, 5 pi over 2, and the same negative values. So the angle can never be an odd multiple of pi over 2. So summarizing the properties of the tangent function, the domain is a set of all real numbers except odd multiples of pi over 2. The range, though, is the set of all real numbers because, remember, the y value can take on values from minus infinity to plus infinity. The tangent function is an odd function. That is, what you see on the right is a negative of what you see on the left. The tangent function is periodic with period of pi. So recall that sine of theta, cosine of theta had periods of 2 pi. Tangent of theta will have a period of just pi. Now, notice that we're going to do cotangent in a moment, but I'm going to show you how we would graph the general functions like tangent and cotangent of omega x plus b. And here is the way I would like for you to do it. I think it's the easiest using your calculator. The values A here denote how large the tangent function can get compared to just a tangent function. And the absolute value of A is called the amplitude. And B is just a vertical addition to the value of y. So we would use the amplitude to determine suitable values for y min and y max on your calculator. Notice that the tangent function will have vertical asymptotes approaching plus infinity, and this should be minus infinity. What you should do is calculate the period of the tangent or cotangent function, and that's to take pi divided by omega. Remember, then the period of sine of theta was equal to 2 pi over omega. For the tangent and the cotangent, it'll be half as much, which will be pi over omega. And therefore, you would set your x min to minus pi over omega and your x max to plus pi over omega in your calculator. Enter the function into the calculator, display it on your calculator, and you'll see 2 full periods of the function. So let's look at a fairly simple one. to start off with. We'll bring up the calculator. And first of all, as we said, be sure that you're in the correct mode. We're going to be doing this in radians, so we do have it set in radians. The function we want to do is 2 tangent of x minus 1. So let's clear this out. We get 2. Notice we have a tangent function of x. And we're subtracting 1 from the function. So the period is still going to be pi. So let's take the window and go from minus pi to plus pi. And since the function could get pretty large, I would go from minus 10 to plus 10 on the y min and y max, and then hit graph. And notice we see the graph is down by 1 and x equals 0. And then we see this other part here. And the period is still pi. And this will repeat every pi radians. Let's try another one. In this particular case, the period is pi over omega, which is pi divided by 1/2, which is 2 pi. So the period is 2 pi. And so we want to show at least 2 periods. Let's go to the calculator. And clear it and put in 3 tangent of x divided by 2. And set our window, since the period is 2 pi, let's go from minus 2 pi to plus 2 pi. Probably minus 10 to plus 10 is good enough. It'll show plenty of the function. So hit graph. And you will see the graph of this function. Notice the period is 2 pi, so we go from here to here is 2 pi, and it begins to repeat. To make it look a little more like this graph, we could expand the window to go from minus 3 pi minus 3 pi to plus 3 pi. And that will give us, 3. That will give us a little more than 2 periods. So there is a graph. From here to here would be 2 pi. Now we're going to look at the cotangent function. And we're going to now pick the values I've circled here for the angle. We're going to start out at 0. Tangent is going to be equal to x over y. And notice at the angle 0, that's 1 over 0, it's undefined. At pi over 6, it's going to be x over y, which is the square root of 3 over 2 divided by 1/2 equal the square root of 3. So on our table for pi over 6, we should see the square root of 3. If you continue to do this for pi over 4, you're going to get x over y, which is the square root of 2 over 2 divided by the square root of 2 over 2 equals 1. And then for pi over 2, it's going to be x over y, which is 0 over 1. So the cotangent of pi over 2 is 0. And notice for the angles 2 pi over 3, it's going to be the same as we got for pi over 3. And for pi over 3, it would be x over y, which is 1/2 divided by the square root of 3 over 2 is equal to 1 over the square root of 3. It's equal to the square root of 3 over 3. So for pi over 3, it's the square root of 3 over 3. Let's check this over here. Square root of 3 over 3. And then going for 2 pi over 3, it's the same as pi over 3 was. If you look at the angle, so the cotangent of 2 pi over 3 is minus the square root of 3 over 3. By the same token, the angle 3 pi over 4 is the negative of the value for pi over 4, which is minus 1. And finally, 5 pi over 6, we get minus the square root of 3. So now if we plot this function, we will get this graph. And if you expand it to several periods, you'll get the cotangent function with a period equal to pi. In fact, let's show how we would graph this. On the calculator, you would have to make that 1 divided by 1 divided by the tangent function. And let's show 3 periods on either side. So let's go minus 3 pi plus 3 pi. And let's go let's keep it at minus 10 to plus 10. And we will then see a graph. The y, the x must have, minus 3 pi plus 3 pi. Gotta watch what you put in. Now we'll graph it. We should see the same thing. So there's 3 periods on either side. And that's the cotangent function. Now, how do we do cosecant and secant? Well, if you look at your calculator, you don't see a cosecant or a secant on most calculators. The period of cosecant and secant with omega equal 1 will all be 2 pi, just like the sine and cosine. So here is how I suggest you graph the cosecant and the secant functions. The period of these functions is the same as the period of the cosine. So the period would be 2 pi over omega. So you set x min to be minus 2 pi over omega, x max to be 2 pi over omega. Enter a over cosine over omega x for secant, and enter y equal a over sine of omega x for cosecant. Display in your calculator and you'll see 2 full periods of the function, and you can adjust the vertical window as needed. So here is a nice neat graph of cosecant function. Notice that in this particular case, we actually graph the sine function in black, and then we took the value of the sine function and divided it into 1. So at pi over 2, the cosecant would be 1 over 1. At 3 pi over 2, it would be 1 over minus 1. At minus pi over 2, it would be 1 over minus 1. And at minus 3 pi over 2, it would be 1 over 1. Then, doing that all for each of the points, you will notice that near pi and near minus pi, the value of the sine is going to 0, so the value of cosecant would either go to plus infinity or minus infinity. So let's do this. Bringing up the calculator, we're going to write that y is equal to 1 over the sine of x. And let's make the window minus pi to plus pi. And let's keep the minus 10 and the plus 10. Oops. Okay, should be 1 over sine of x, 1 divided by sine of x. That should be cosecant. And now we have a full period. Let's go and show twice as many. Let's go minus 2 pi to plus 2 pi. And now you basically will see what you see on the graph here. And the period is 2 pi. Now let's do secant of x. Notice you can get it by graphing the cosine of x and then taking 1 divided by the cosine of x, and that'll give you secant. So let's do this. Put in y equal 1 divided by cosine of x. Looks like we can keep the same periods that we just had, or the same window size. And when we graph that, we now see the graph of the secant function. In this example, we're going to calculate and graph y equal 4 cosecant of 1/2 pi times x. The period, first of all, we'll write that y is going to be equal to 4 divided by sine of pi over 2 times x. The period is going to be the same as the sine function, which will be 2 pi over omega, which is 2 pi divided by pi over 2 equals 4. So the period of this function is 4, and if we want to graph using our calculator, let's go with y equals 4 divided by sine of pi times x divided by 2. And to set our window, we need from minus 4 to plus 4. And I would keep the y min and y max the same and graph the function. And notice that we have 2 periods of the cosecant function. And that is the lesson for today.